Okay, here is number 9 through 12, and we are solving systems of inequalities, which means we will be graphing some lines here, and the shading, we are looking for the overlapping of the shaded parts for our solutions. So right now, in number 9, our equation, both equations are written in y equals mx plus b format, and um, we can start graphing right away. So what we're looking at right here is the positive 1 is our y-intercept for this first equation. So I'm going to put a dot on positive 1. And my slope right here is negative x. So that's negative 1. So my slope is negative 1 over positive 1. So that means I'm going to be going down 1 and right 1. Down 1, right 1. Down 1, right 1. I could go back to the intercepting and go opposite. Up 1 and left 1. You can see my lines are going to be, my points are going to be in a line here. So I can kind of see up 1, left 1, and go through and create the, um, to create the line. So here, this is my line. Let's see here. Oh, okay. So then, that is my first line. And now I have to think about the shading here. If I plug in 0, 0 into that equation, that gives me 0 is greater than 0 plus 1. 0 is greater than 0 plus 1. Well, 0 is greater than 1, so I want to be shading towards the point 0, 0. And I'm going to use a highlighter here to show where the shading is on this. So I am shading towards that point 0, 0 because that's one of the solutions. Okay? Now let's look at the other equation, inequality. My y-intercept on that is negative 3. So I'm going to go down to negative 3. My slope is negative 5. Well, that means I have negative 5 over 1. If I go down 5, that's going to get me off the graph. So I can go up 5, but I have to make sure if I go up 5, I go left 1. So 1, 2, 3, 4, 5, left 1 unit, and there's my point. So now I'm going to graph this, and I have my line goes through there. Now I have to figure out the shading. And now for testing the point 0, 0 in the second equation, I will get 0 is greater than 0 minus 3. And we have to determine, is 0 greater than negative 3? No, negative 3 is smaller than 0. So what we want to do is we want to shade away from the point 0, 0, which means I'm going to be to the left of that line, or below that line, however you want to look at it. And I look at my overlapping. And it's kind of hard to see with this green. Maybe if I do a lighter color here. Well, let me see here. No. Okay. Let's go with that color green. Yeah, I can see that a little bit better. All right. So if I look at the where I'm shaded here, I'm shaded down below this line here, but then here. So you can see this little part is the green, but not yellow. And then over here is yellow but no green. And what I'm looking for is where do the green and yellow overlap, which is right here on that part of the graph. And that would be my solution set for that graph. For number 10, I'm going to have to put these equations into slope-intercept form. So I'm going to subtract the 4x. I'm going to get 3y is less than negative 4x plus 3. And then I divide by the 3. And I get y is less than negative 4 thirds x plus 1. So that will be the first equation to graph. And then over here, I'm going to subtract x. And I get 3y equals negative x minus 6. Divide by the 3. And I will get, oh, not equals, but less than or equal to. And I get y is less than or equal to negative 1/3 x minus 2. And I just realized a mistake in the first problem here, that I didn't pay attention to the fact that that needs to be a greater than, it's not equal to for that second equation. So the only thing I need to do is change that line to be a dashed line. And so now you can see that's a dashed line there. The other line is a solid line because the line underneath the inequality. So when I do this other problem now, I'm going to be more careful. So this first line is going to be a dashed line because there's no line under the inequality. So I'm going to go up here and I plot the y-intercept of 1, and then my slope is negative 4 thirds. So that means I'm going to go down 4 and to the right 3. So when you have a negative number, only one of the numbers, when I have a negative fraction, only one of the numbers is negative, the other one is positive. So down 4 to the right 3, or I could go up 4 and left 3. And when I go over and do this line, I'm going to make sure I have a dotted line. And there's my line there. And now I have to shade. Let's go with, a light green. And let's see, if I plug in the 0, 0 point, 0 and 0, is that less than 3? Yes. So 0 plus 0, 0 plus 0, is that less than 3? Yes. So now I'm going to go over and graph to include the 0, 0. Okay? And now I'm going to graph the second equation. And with this second equation, my y-intercept is negative 2, so I'm going to go down to negative 2. Whoops. Need the pen. So negative 2. My slope is negative 1 over positive 3, so negative 1 and positive 3 is right there. And I could go positive 1 and negative 3, so up 1 and left 3. Now that one is a solid line. So when I do this one, I want a solid line to graph this. And there's my line. When I test the point 0, 0, it doesn't matter which inequality I use, either the original or the one I have over here. I could do 0 is less than or equal to 0 minus 2. Is 0 less than or equal to negative 2? No, negative 2 is the smaller number. So that means I'm going to be shading downward. And I'm going to make this a little bit lighter. Okay. So then we are shading away from the point 0, 0 because this answer right here is false. So we do not want to include 0, 0 in the we don't want to include what? 0, 0. Wait, wait, wait. Let me go back and do this over. We don't want to include the 0, 0 in our shading. All right. So that is right here down below that line, away from the 0, 0. So then I can see my overlap. Here I don't have any overlap. Up here I don't have any overlap. So you can kind of see this brighter green here is where I'm going to shade. So I'll go ahead and shade that with the purplish color again. And that's going to be down like that. Follow the dash line over there and the solid line up here. And then I shade down below like that. Okay, let's go ahead and look at number 11. On your review, this was a negative. Sorry. On the review, this was a negative 2x plus y is less than 8, but I need to change that so that it's a positive, and then the graph on the solutions is correct if you have the paper copy. Otherwise, you'll see what I do for this as I go through the problem. All right, so anytime I have this y is greater than 0 or just x is greater than 1, over here I have the x greater than 0 and x is less than 7. Those are vertical or horizontal lines going through at the 0, the 1, the whatever number you have. So for y, I'm looking at where y is 0. Y is 0 at the origin, and the y values go up and down. So my line has to go sideways through the y-axis. So when I graph that line, I'm going to graph this with the drawing tool here, and I'm going to make it, we'll make it a nice bright blue. Okay, so when I graph this line, there's my line. And for y to be greater than that, I'm going to be shading up, and I'm just going to draw arrows since I've got a number of lines to be graphing here. For x is greater than or equal to 1, I go over to x equal 1, and I draw a vertical line through x equals 1. And greater than 1 is going to be to the right. Okay? Now, for y is less than or equal to negative 1 half x plus 4, I'm going to go up to 4 and plot my point. I'm going to go down 1 for the negative 1 half, so down for the negative 1, and positive 2, so positive 2, down 1, right 2, down 1, right 2. And now I have that line. And for my shading, I'm going to plug in the 0, 0 just to see if I'm shading down or up. So if I put in 0, is that less than 0 plus 4? Yes. So that means I'm shading down. So far, if you look at this, I'm shading in this triangular region right here. So we'll see what this next line does for us to see if it cuts off part of this triangle. And I'm going to need to put this in slope-intercept form. So I'm going to subtract 2x from both sides. I get y is less than negative 2x plus 8. And so my y-intercept is 8. I'm going to go up to 8, plot my point. Negative 2 goes down 2 to the right 1, down 2, right 1, down 2, right 1. You can see I'm cutting off some of this triangle here. And there's my line. If I plug in 0, 0, is 0 less than 0 plus 8? Yes, 0 is less than 8, so I'm going to shade down towards 0, 0, which means I'm going into this area right here. If 0, 0 did not work, then I'd be shading over here. But it's going down towards there. And so this one I'm just going to fill in with red. And here is my shaded area in that little diamond shape. Okay? Now let's look at number 12. X is greater than 0. So x greater than 0, where x equals 0 is on the y-axis, going straight down through 0 on the x-axis. Shading greater than that would be to the right. Okay? X is less than 7 has got to be a dotted line, which I just realized on this one over here that needed to be a dotted line. So I need to change that. Okay, so there you go. So that's part of that graph. Um, and yeah, so x is less than 7 is a dotted line. I'll go ahead and change that now. Okay, and for less than 7, we are shading to the left. I also added, no I didn't. Now I have y is less than or equal to 1/4 x plus 5. So I'm going to go up to 5, plot my y-intercept. 1/4 means up 1 and to the right 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Down 1 over 4. Okay, and that line is going to be like this. And it is a solid line. If I plug in 0 and 0, I will get 0 is less than 0 plus 5. That is true. So I'm going to be shading down towards the point 0, 0. So far I'm in this area right here. Now, for this last one, I need to subtract x. Put this in y-intercept form, slope-intercept form. So 2x is greater than negative x plus 4. Divide by 2. And I get y is greater than negative 1/2 x plus 2. So I'm going to go up to 2. And then negative 1/2, down 1 to the right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2. Okay, I could also go up 1 and left 2. All right, and this is a dotted line. So when I go in here, I need a dotted line. And I graph that. So there's my dotted line. And my shading, if I plug in 0, 0, I get 0 plus 0. Is that greater than 4? Yes. No, 0 is not greater than 4. So I need to shade away from the point 0, 0. And if I look at all my arrows, I am in this little trapezoid area, and that is my shading inside here for my solution set. And we're done.